Welcome back, students. Today's discussion is for class 2 and the topic is halofoam reaction. Now, this halofoam reaction is given by those compounds which contain CH3 C double bond O group, or the compound should contain CH3 CH OH group. So this halofoam reaction is given by those organic compounds which contain CH3 C double bond O group or CH3 CH OH group. Okay? So let me write the reaction. Let me take an example. CH3 C double bond O CH3. So this compound contains CH3 C double bond O. Whenever such compounds are treated with halogens, halogen is represented generally as X2, and in presence of NaOH of S, you will be getting, the reaction will give you halofoam, that is CH plus, now this is ketone. This ketone will be oxidized to carboxylate anion. Okay, so here CH3 C double bond O minus Na plus, and the byproducts are sodium halide and water. So, whenever organic compounds containing CH3 C double bond O group or CH3 CHOH group reacts with halogen in presence of NaOH, you will be getting halofoam, and the salt of carboxylate anion. Look here we are having 1, 2, 3 carbons. 1, 2, 3 carbons. One carbon will always come in the halofoam part. The remaining two will be going as, or will be oxidized as carboxylate anion. Okay? Now, same reaction. This halofoam is for all halogens, chlorine, bromine, iodine. Now, our main focus is on iodoform reaction. Okay? So, iodoform reaction. So, in iodoform reaction, the reaction is exactly the same. The difference here is in this X2 group. This X2 now, since it is iodo now, this X2 has to be iodine. So, if X2 is substituted with I2, then the products obtained here will differ in this X only. So let me rub this part. Here you will be having I2, and here also you will be having Na. Now this CHI3 is known as iodoform, and it's a precipitate. And the color of the precipitate is yellow precipitate. So this will act as a test. Now see, this test is given by those compounds which contain CH3 C double bond O or CH3 CH OH. Okay? And this is yellow precipitate. Now, application of this iodoform reaction will be used in distinguishing between the compounds. For example, I hope you have noted it down. Now let me take one distinction done by iodoform reaction. Suppose you have two compounds, CH3, C double bond O, CH2, CH2. This is 1, 2, 3, 4, 5. Similarly, you have CH2, C double bond O, CH2, CH2, CH2. Here also, it's 1, 2, 3, 4, and 5. So, both of these are having the same molecular formula. The difference lies in carbon and carbon. Now look here, this carbon here it is present at carbon number 3 and here it is present at carbon number 2. So it is pentane 3 on, and this compound is pentane at 2 position we have carbon and carbon, therefore 2 on. Now these two compounds look in many respects the same, and it can be distinguished. It can be distinguished by making use of Halofoam reaction. Now whenever these two compounds are separately treated with iodine and NaOH, here also it is treated with iodine and NaOH. Now here, since you have CH3 C double bond O group, this part, it gives you Halofoam reaction that we have just discussed just now. Therefore, here it gives you yellow precipitate of CHI3. Whereas in this case, this compound, this C double bond O is not attached to CH3. Here it is only CH2. This side also is only CH2. Therefore, this compound does not give you Halofoam reaction. Therefore, here it doesn't react at all. That means you don't obtain yellow precipitate. No reaction takes place. So there is such distinctions by Halofoam reaction can be applied to other compounds as well. You just have to see whether it contains CH3 C double bond O group part in that compound or CH3 CHOH. Hope this is clear. Now let's move on to the next topic. The next topic is also a very important name reaction. That is Cannizzaro reaction. So the next topic is Cannizzaro reaction. CANNIZZAR Cannizzaro reaction. Now, in Cannizzaro reaction, you have to see whether alpha hydrogens are present or not. Now, this Cannizzaro reaction is given by those compounds which do not contain alpha hydrogen. Let me tell you what is alpha hydrogen here. CH3 C double bond OH. Please look at it carefully because this name reaction and the next is based on whether alpha hydrogen is present or not. Now here, what is our functional group? This part is our functional group. This carbon which is attached to the functional group is your alpha carbon. This carbon is alpha carbon, and the hydrogens which are attached to this carbon are known as alpha hydrogens. These are alpha hydrogens. Okay, so I told you Cannizzaro reaction is given by those aldehydes which do not contain alpha hydrogen. For example, formaldehyde, Formaldehyde is HC double bond OH. So this is our formaldehyde. This compound doesn't contain any alpha carbon, therefore there is no question of alpha hydrogen. Therefore, such compounds will undergo Cannizzaro reaction. Now in Cannizzaro reaction, two molecules of those aldehydes which do not contain alpha hydrogen react in presence of concentrated base. For example, so let me take two molecules. One molecule I have taken it over here, the other molecule here. In presence of base, concentrated NaOH. Okay? Listen to this very carefully. Whenever aldehydes which do not contain alpha hydrogen reacts in presence of concentrated base, one molecule will be oxidized. If it is oxidized, you will be getting carboxylic anion, and the other molecule will be reduced. So this is a one molecule will be oxidized, the other molecule will be reduced. So one carbon, whenever this compound containing one carbon is oxidized, you will be getting HCOO. And if this compound is reduced, what will you get? On reduction, you will be getting alcohol. So alcohol with one carbon is CH3OH. So this is oxidized form, and this is the reduced form. So in general, I have already taught you in class. Like, let me write this here. Alcohol, whenever they are oxidized, they give you carbonyl compounds. And on carbonyl compounds, on further oxidation, will always give you carboxylic acid. And this is oxidation. Okay? Alcohol oxidation will give you carbonyl compound. Carbonyl compound on further oxidation will give you carboxylic acid or salt of carboxylic acid. The reverse is true when they undergo reduction. When carboxylic acids are reduced, you get carbonyl compound. When carbonyl compound are further reduced, you will be getting alcohol. So if you remember this trend, which I have already taught you, okay, in class, then it will be very easy to write down Cannizzaro reaction. This molecule, one molecule is oxidized to salt of carboxylic acid, and here the other molecule is reduced to alcohol. Hope you have noted down this Cannizzaro reaction. Now, the mechanism of Cannizzaro reaction is also the universalist. So let's discuss that. Mechanism of Cannizzaro reaction. So we have this compound HC double bond OH. Whenever it reacts in presence of concentrated NaOH, NaOH will be dissociating as Na plus and OH minus. Now this is less electronegative compared to oxygen, therefore this is delta negative, this is delta positive, this carbon is delta positive. Now this negative will be attracted towards this carbon center, and hence we have bond formation taking place between oxygen and this carbon. So now let me write the product HCO minus, this side H, and here what has come? this OH group is bonded to this carbon atom now. Therefore, we have OH. Okay? So, we have taken in Cannizzaro reaction, we were taking two molecules. So, this one molecule has converted to this part. Now, in the second step, so let me write it here. In the second step, what will happen is other molecule of formaldehyde will be used. So, H, C, double bond O, H. Now, whenever this negative charge comes back and forms a double bond here, this hydride, please look at it carefully. This hydride means hydrogen along with this bond will migrate to this carbon center. Okay? In this case, these two molecules will be having separate compounds. What has happened? Like in other cases we have discussed, there was bond formation. Here the bond formation between these two molecules will not take place. What has happened? Only this part from this particular compound has been transferred to this carbon. Okay? So let me write this part in. Here we are remaining with this part, that is H, C, double bond O, OH. Now since this hydrogen has come over here, okay, then let me write this part now. Here, H, C, O minus H, H. So this hydride has been bonded over here. Now, in the next step, what will happen is this negative charge will take this proton. Okay? So this negative charge will take up this proton, and as a result, here the bond is present between these two. Oxygen will be having a negative charge. Okay? So let me write this part now. H, C, double bond O, O minus I'm writing it over. Okay, this O minus I written it over. Plus, the other compound is what? See, it is 3 hydrogens attached to carbon. That means CH3OH. That is CH3OH. This is methanol, and here since it is having a negative charge, and in your reaction condition, this Na positive is present. Therefore, this Na positive will be attracted towards this negative sign. As a result, you get these two compounds. This is the oxidized form, and this is the reduced form. This mechanism is very, very important. Okay? Hope you have noted down this one. I urge you to practice this mechanism reactions. As you keep on practicing, it becomes more and more simpler. So now let's move on to our next topic, that is in some respect just reverse of this reaction, just the opposite of this reaction. Okay? The next topic is aldol condensation. Now, this aldol condensation and Cannizzaro reaction, I told you, they are just somewhat opposite in nature. This aldol condensation will be given by those aldehydes and ketones which contain alpha hydrogen. Okay? Please note it properly. This reaction is given by those aldehydes and ketones which contain alpha hydrogen. Whereas in Cannizzaro reaction, the compound did not have alpha hydrogen. So here, let's write. The next topic is aldol condensation. So this aldol condensation is just the opposite of Cannizzaro reaction. reaction. Okay, now in alkyl condensation, those compounds which contain alpha hydrogen will give or undergo alkyl condensation in presence of dilute alkyl. So if I give you example, that will be more clear. So this is your functional group. This is alpha carbon and these are your alpha hydrogen. So whenever two molecules of such compounds reacts in presence of dilute alkali, that is NaOH. Okay? You can write the product in just one step. For that, please look at it very carefully. This is also CH3 itself. So I written as CH2H. Now this alpha hydrogen, one of the alpha hydrogen from this compound will go and get bonded with this oxygen. Okay? And this carbon, from where this alpha hydrogen has gone, will be bonded with the carbonyl carbon. Means condensation takes place. What takes place? Condensation. These two molecules will, after the reaction, will come together and form the one single product. So let me repeat it once again. The alpha hydrogen from another molecule will go and get bonded to the oxygen, and this carbon, this alpha carbon, will be bonded with this carbonyl carbon of another compound. So a bond formation takes place between these two carbons. Now let me write the reaction. So I'm starting with this part. CH3 CO. Now to this oxygen acid, hydrogen, OH. Now this hydrogen, instead of writing here, I'm writing it below here, so that I can write this carbon chain in a straight chain itself. So this hydrogen is over here. Now this carbon gets bonded with this carbon. Okay? Look at it. So this carbon is bonded with this carbon, CH2, C double bond OH. This part is very, very important. Please look at this part. Okay? Bonding order here. So this is the product that we get after alkyl condensation. And why it is named as alkyl condensation? Because see, Al means aldehyde. So here in this compound you have aldehyde group. This is aldehyde group, Ald, and OL means alcohol. In the same compound we have O also, alcohol. Therefore, this reaction is known as alkyl condensation. And the name of this product would be, see, this is alpha carbon, this is beta carbon. So, at beta position what we have? Hydroxide group. So, beta hydroxy aldehyde. So, aldehyde. Okay, this is your product that we obtain after alkyl condensation. Now this compound, if it is heated, okay, if it is heated in presence of say dilute HCl, what will happen? Elimination of water molecule takes place. If this is given, okay, then if heat is given, if this product is stable, but if it is heated, then a molecule of water will come out from here. So let me write it once again here. So here we have OH2, and here it was CH2. I have written CH. So this water molecule will be removed upon heating, and as a result, what will happen? Double bond formation takes place here. So we have a compound CH2, C, H, double bond, CH, C, double bond we have this product after elimination. Once by the water molecule has been removed. Okay? So if in your reaction, if they have asked you only other concentration, then you can end your reaction till here. Okay? You don't have to go it further. But in case if they ask you what is the product obtained after heating this product, then this is your answer. Now, the mechanism of this is also there in your syllabus. Hope you have finished noting it down. Now let's do the mechanism part. This was to predict the product in just one single step. Now mechanism is very simple. Mechanism of Halo-condensation. Okay? So we have two molecules of aldehyde or ketone which contains alpha hydrogen. Now one molecule in presence of NaOH, that is dilute NaOH. This is Na plus, this is negative. Here the CS3. These alpha hydrogens are acidic in nature, means they can be easily removed. So what will happen? This OH minus will take up this proton. You will be having a negative charge over carbon. So CS2 minus C double bond OH. Okay? This is the one molecule which has been converted into this negative charge. We have another molecule also. Now another molecule of acetaldehyde CS3 C double bond OH. This is delta negative, this oxygen is delta negative, this carbon is delta positive, as I have already told you. Now, this negative charge will be bonded with this carbon. Okay? Here, it's very important. Please look at it carefully. This carbon, alpha carbon of one molecule gets bonded with the carbonyl carbon. Carbon which contains C double bond O. Okay? Will be bonded with this carbon. And we get a condensed product. So let me start the compound from this side. See, while writing the product in one condensed form, you have to see the bond order. So I have started from here. CS3 CO minus this H. I am writing it here down so that I can have this carbon chain in a split chain. Okay, so now this carbon is bonded with this carbon. So CH2 C double bond OH. And the last step is very simple. The H+ ion which was lost in the first step will be taken over by this negatively charged oxygen, and hence we get the final product. That is CH3 COH H CH2 C double bond OH. Okay? So one molecule has been converted into anionic form. This anion will get condensed with another molecule. Okay? To get a condensed product. And the final step is very simple. This negatively charged oxygen takes proton and gets converted into OH. Hope this is clear? Now, here we have taken the same molecule, like acetaldehyde, one molecule of acetaldehyde reacting with another molecule of acetaldehyde. Now, your assignment, your home assignment will be to write the product when different compounds are reacting with each other. Okay, like in this case, CH3, CH2, C double bond O H in presence of valued H2 NaOH. I'm just telling you to write the product. Now please look at this. This is alpha carbon and these are alpha hydrogen. Therefore the bond formation has to take place from here. Okay? You can refer to your book for solving this reaction. Let me tell you, you'll be getting 4 products. Product 1, 2, 3 and 4 products. Okay? So your assignment is to complete this. What are these 4 products? And you will send the clips of your this assignment in my WhatsApp number. Okay? Please do that. Another assignment would be this compound. Two molecules of benzaldehyde reacting in presence of concentrated NaOH. Okay, so here you will get the 2 products, that is A and B. Please complete these assignments. We will see you in next video.